Hello and welcome back to Calculus 2, section 6.6 on surface area of revolution. We are already familiar with rotating a function around an axis to create an object that was radially symmetric. So we talked about the baseball bat, the light bulb, the different football, and then we created a whole bunch of other objects by rotating a function around. So if I have some kind of a function f of x, oh, I'm going to regret that, and I rotate this around x-axis, I will get the same function on the other side. It's getting there. And there will be an area over here. So we are calculating the area that wraps around the object. So we are looking for the surface area. Now, not here and not here. So not those circles on which it stands or the top. So let's say this is a vase. If you are to stand this up, you want to come up with some kind of design, so you need to give the dimensions to arts people and say develop something that fits here. What is the formula? The formula for this is going to be the length of curve formula times the rotation, right? So if I'm calculating the surface area over here, denoted with S, we can also call it A for area. So surface area is going to be 2 pi. Remember, we are rotating, right? So we are going to have pi or 2 pi. It's 2 pi. Integral A to B. And now you're going to have f of x times the square root of 1 plus f prime squared. So that's the length of the curve piece, right? We just had it. We are the only new features in this formula are 2 pi and f of x. That's new. Other than those, you take those two out, it's length of curve. So it's length of the curve because that top line is f of x. And you are going to multiply that with the function, which is the radius, and then you have the 2 pi. Guys, I hope you see between this and this is the 2 pi r, which gives you one dimension times this for the second dimension, right? So you have your 2 pi r times. And we're going to have the partner in crime for the y. So that's the CD f of y, square root of 1 plus f prime squared of y dy. So this is the formula number 6 from the beginning of the semester. Remember, your job is to remember these formulas. Your first exam is only those formulas, and then Calc 1 integration if you are able to do that. So since we have a lot of time, let's first do a vanilla problem. That would be, let's say, a cone. Let's make a cone. And figure out the area, surface area of the cone. And then we're going to take something from the textbook and then call it a night. So here we have a cone. So I'm going to take a linear line, so segment, that connects number 3 on x-axis and 1, 2, 3, 4, 5 on y-axis, which will give me the function f of x. Well, yeah, sure. We'll rotate on the y-axis here to create the cone you guys are used to. And we would like to know the surface area of this. Now, f of x here is going to be negative 5/3 x, because it's 5 units up, 3 units to the right, but the line goes down. So it's negative 5/3, plus 5, because it is your... Ooh, I forgot to give you rotations. Holy nightmare. Rotation on x, and the blue one is rotation on y. So x and dx and y and dy. And that's important because that's how we know that we have to switch this formula. So my formula here is y equals negative 5 over 3x plus 5, but I have a rotation on y, which means I need the dy for surface area. So if I need dy, then I need x equals f of y. And that is what triggers to flip this, because I have y as f of x, but I need x as f of y. So to flip it, we can multiply everywhere, let's say by 3 first. Why not? Multiply everywhere by 3, you get 3y is equal to negative 5x plus 15. Then 3y minus 15 is equal to negative 5x. And then divide everywhere by negative 5. So x equals to negative 3 over 5 y plus 3. So when we flip, we get the formula we get to use. So now, since I am rotating on y, I will be using s equals 2 pi, and I need y limits, which are 0 to 5 in this case. I have my f of x, which is negative 3/5 y plus 3, times the square root of 1 plus, and I need derivative squared. Well, the derivative over here, which is f of y prime, is just negative 3/5. Remember, this is your f of y, because the function is in terms of y. So y is your input variable. So now I just need to square this one, and that's going to give me 9/5 over here, and I have dy. So I'm just going to move this integral a little bit down because it's crammed here for no reason. There we go. Square. Oh, 25. Yes. Negative 3 squared is 9. 5 squared is 25. I was just testing if you're paying attention. Perfect. 2 pi integral 0 to 5. And now we have, I can kick 3 outside actually in front of the parenthesis. I have negative 1/5 y plus 1. And then over here I have a square root of 25 plus 9 is 34 over 5 dy. And now I'm going to kick all of the 25. Still testing. Just one person is paying attention. I'm going to kick all of the constants outside. Those are the numbers. So kick them all out. It becomes 6 pi times square root of 34 over 5. Now I took the square root of 25. You see that the square root is not extending down anymore. And all I have to integrate here from 0 to 5 is this negative 1/5 y plus 1 dy. That was a nice one. So we have 6 pi root 34 divided by 5. And now I have over here y squared. So it's going to be negative y squared over 10, because y, the integral of y is y squared over 2. 2 times 5 is 10. So we have that. Plus y computed from 0 to 5. Since these are polynomials, we don't have to worry about 0. I have 6 pi root 34 divided by 5. Plug in 5, I will get negative 25 over 10 plus 5, and then minus, I'll put minus 0, but we don't care. And now we can compute this. We can cancel by 5 over here, so that's going to be 5 halves. And then this one, the second one, because it's halves, will become 10 halves. So the whole parenthesis, 6 pi root 34 over 5. The whole parenthesis over here is 10 minus 5 becomes 5 halves. And that will reduce 5s, and this reduce that. So we have 3 pi root 34 for the surface area just for the cone. So you know the cone has that circle on which it stands? That's not included. Just the surface area of the outside. So if you have the ice cream in this thing, the part that you're holding in your hand, that's the surface area for it. It's mainly arithmetic and Calc 1, shoveling numbers and expressions. If you know the formula, this should not be an issue. We have another 14 minutes left. We're going to pick one more example from the book, from homework section on 6.6, and call it a night. We will finish the chapter 6 on Thursday. So let's see. Thank you. 6.6. Let's see what we have over here. Oh, that's nice. How about 18? Looks interesting enough. Y equals square root of 5x minus x squared on 1 to 4, rotated about x-axis. Problem 18. Now, we already know the formula. We just plug everything in and we go on. We just need to find the derivative first, guys. We need that f prime so we can square it, right? So I need to find y prime first. Or f of x prime, whatever you want to call it. The way to find the derivative for square roots, it's going to be 2 times the same square root in denominator, and then its derivative on top. In this case, 5 minus 2x as chain rule, right? Because you have, this was not root x, it was root of the mass. So the derivative of this mass goes on top. So that will be the derivative. And now all I need to do is to put 2 pi integral 1 to 4. That's provided to us as our limits of integration. And now we have the function, which is the square root of 5x minus x squared, times the square root of 1 plus, and now I have 5 minus 2x over 2 times square root of 5x minus x squared, everything squared dx. Lock the doors. No one is leaving. We'll finish this. Looks terrible, right? Not a problem at all. See that square? It's going to kill the square root in the denominator. And when I multiply 2 square roots, it's going to cancel. It's going to work out as a joke at the end. Let's see. 2 pi, 1 to 4. Copy the first square root. The second one, first we get everything squared. So that's 5 minus 2x squared divided by 4 times 5x minus x squared. So the square changed the 2 into a 4, and then the square killed the root in denominator. Now, I am going to multiply these two. Oh, I forgot dx. Holy nightmare. Now I'm going to use the algebra rule. Square root of a times square root of b is square root of ab. Meaning, I'm going to multiply the arguments of these two square roots, and we'll go from there. So I have 2 pi integral 1 to 4, and now I have one big square root. When I multiply 5x minus 2x, keep this, guys, in your head as a unit. Right? This is like a 1 unit. Multiplying 1, and then multiplying the second messy term. So when I multiply this into 1, it just is that, right? And then when I multiply this into the second term, they will just cancel here. So the second term remains as 5 minus 2x everything squared divided by 4. That's all it is. So when it multiplies into 1, becomes 5x plus minus x squared. And then when I multiply into a second term, the term from denominator will cancel with it. So you just have numerator divided by 4. And now we'll just shovel more algebra. 2 pi, integral 1 to 4. And the first order of business is to find the common denominator, and then I have to square so I can add like terms. So square root of, this becomes 20x minus 4x squared over 4 plus over 4. And I have dx. So what I did is I found the common denominator. I need to multiply over here. I put over 1 and then times 4 for each one of these. And now I have to FOIL on the second one to multiply it out. I have 25 minus, now the middle term is 2ab, so that's going to be 20 minus 20x. Because it's 2ab, right? You have 2, and then you have a 5, and then you have 2x. Plus 4x squared. Now we add like terms between two fractions. Guys, over 4, I'm going to factor, kick it as a half in front of the root, kick it as a half in front of the integral. It kills this too. So it's pi, integral 1 to 4, square root of negative 4x squared, positive 4x squared, gone, positive 20, negative 20. Oh, okay, I'll use it. 25. Since I was thinking it's going to be some expression there. It's just 25 left. Okay, so square root of 25 dx. This is 5 pi x from 1 to 4, which is 15 pi, because 4 minus 1 is 3. 3 times 5 is 15. So 15 pi for the surface area of revolution on this problem. Ta-da! Be gone. See you in 2 days.